In this video, we will be using the representation of a path to evaluate line integrals. So before we move on to the problems, I just want to mention a point. That is, in case of complex line integrals, the integral value, the value of the integral does not only depend upon the endpoints but also on the path. Okay, that is, if I'm integrating, say, some function from between 2 points, say z0 and z1, the function is, say, some function f of z dz. So even if I'm integrating the function between these points z0 and z1, but I'm using two different paths. Say first path is first path that I'm using is c. The second path is, say, some other path c star. The same function f of z dz between the same point z0 and z1. We have these 2 points, say z0 and z1. Okay, I'm using two different paths. So this path I'm going to call it as c. This different path I'm going to call it as c star. Okay. So the value of these two integrals need not always be same. It may be same, may not be same. We have already seen that if the function is analytic, then it will be same. That is the first evaluation method. It does not depend upon the endpoints. Okay, but if the function is not analytic, then we cannot guarantee that the values will be same. Okay, it may be same, it may not be same. Now we'll be illustrating this fact using an example, and in this example we will be using the representation of a path to evaluate the given integral. So the question is like this: integrate f of z equal to real part of z between 0 to 1 plus 2i. Now real part of z, we know it is x, so we have to integrate x from 0 to 1 plus 2i. First we have to integrate the function along this path c star. This is the first path along which we have to integrate, that is between 0 0 to, that is 0 0 means 0 plus 0i, and to 1 plus 2i, that is 1 2. So we have to integrate this function from 0 to 1 plus 2i along this path. Okay, in the second part, b is along c consisting of c1 and c2. Second path is this one. Second, you have to integrate this function along this path. This is your path c, which is actually a union of two paths c1 and c2. So this along this path. So we have this point here 0 0, and then we have this point here, say 1 2, that is 1 plus 2i. So first we are integrating it along this path. Second, we are going to integrate it along a different path like this. This is the second path along which you are going to integrate. Okay. Okay. This is the second path along which we are going to integrate. Now we'll do this in the next page. Now, the first question was to integrate it along this path from 0 0 to 1 2. That is, this is the path c star. Okay, c star is the line joining 0 0 and 1 2. So if you want, we'll first write down that equation of that straight line. We know that equation of the straight line is y equal to 2x, but if you want, you can use this formula: y minus y1 by y1 minus y2 equal to x minus x1 by x1 minus x2, where x1 y1 is the point 1 2, x2 y2 is the point 0 0. So y minus 2 by y1 2 minus 0 equal to x minus 1 by 1 minus 0. Now y minus 2 is equal to, I'm taking 2 to the other side, 2x minus 2. So 2 gets cancelled on both sides, y equal to 2x. So the equation of the straight line is y equal to 2x, but we have to write it in the parametric notation. So what you have to do is just replace this x equal to t. Then what is the value of y? Y equal to 2t. Now I have replaced x equal to t. So what is the limits of x? X varies between 0 to 1. Okay, this is the point 0, this is the point 1. Okay, so x varies between 0 and 1, so t, x equal to t, so t will also vary between 0 and 1. So the parametric equation of the curve c star is z of t equal to x of t plus I into y of t, that is x is t, so t plus y is 2t, I into 2t, where t varies between 0 and 1. Now what will be dz? Dz will be d by dt of t is 1 plus 2i into dt. So integral over c real part of z dz is equal to integral over c x dz, which is integral over x is t and dz is 1 plus 2i into dt, and t varies between 0 to 1. So 1 plus 2i is a constant, we can take it outside. Integral t is t square by 2 within the limits 0 to 1. So that is 1 plus so you will have 1 plus 2i into this t square by 2 within the limit 0 to 1 is 1 by 2. So I am having 1 plus 2i by 2, which is 1 by 2 plus I. Now we will do the second part of the question, that is along C containing C1 and C2. Along this path we are going to integrate. Okay, so B is C along C1, this path C, which is consists of two piecewise curves C1 and C2, piecewise continuous curves. So that is C1 is the line joining 0 0 to 1 0. So you are having y equal to, so what is the equation of this line? This equation of this is the x-axis, so it is y equal to 0 and x equal to t. If I am writing the parametric notation, y equal to 0, x is t, where t varies between 0 and 1. So that is the equation of this line segment joining 0 0 and 1 0. So y equal to 0, x equal to t, where t varies between 0 and 1, because x, the value is between 0 and 1. So z of t is x of t plus I into y of t. So x of t is t, I into y of t is 0. So z of t is just t within the limits where t is within the limit 0 to 1. So dz is dt. So integral over c1 real part of z dz is equal to integral over c1 x dz, which is integral x is t, dz is dt, 0 to 1. So t square by 2, integral of t is t square by 2 within the limit 0 to 1. So the answer is 1 by 2. Now c2 is this line joining 1 0 to 1 2, that is 1 plus 0i to 1 plus 2i. Okay, so the equation of this line is x equal to 1. So equation of this line is x equal to 1. So you replace y equal to t, where t varies between 0 to 2. So that will give you the equation of this line segment joining 1 0 to 1 2, x equal to 1 and y equal to t, and t varies between 0 to 2. T varies between 0 to 2 because t is equal to y, and the limits of y is between 0 and 2. So that is why we are taking t varies between 0 to 2. Now z is x of t plus I into y of t, that is 1 plus I into t. Now dz is d by dt of 1 is 0 plus I into d by dt of t is 1. So dz is I dt. Now we have integral over c2 real part of z dz is equal to integral over c2 x dz, which is integral over x, the value is 1, dz was I dt, integral is between 0 to 2. So I can take it outside. So t between 0 to 2 is, so the answer is 2i. Now integral over c real part of z dz is, c consists of c1 and c2. So we have studied, if c is split into two curves, we can actually write integral over c as integral over c1 plus integral over c2. So the value we calculated now, it is 1 by 2. Integral over c1 is 1 by 2. Integral over c2 we found it as 2i. 1 by 2 plus 2i. Now you can see, although we are evaluating these two questions between the same points 0 0 and 1 2, the first answer we got was 1 by 2 plus I. The second answer, when we are taking along the path c1 union c2, we got it as 1 by 2 plus 2i. The first one was 1 by 2 plus I. So the answers differs, that is result in A is not equal to result in B. So the conclusion is that if the function if you are integrating the function between the same points, if the path is different, the answers may be different. Okay, in some cases they may come out to be same. So that point also we illustrated, and we also illustrated how to use the parametric representation of paths to evaluate integrals. Thank you.